Hey everybody, so today we've got a really important and exciting topic for you. We're going to be going over the string class in more detail now that we've learned that strings are actually objects and how the objects differ from primitive types. So we're going to learn more about strings and their different behaviors that we can invoke today. We're also going to be going over the number formatting classes because as you've seen when we print out doubles, they can be really long, and it's important to be able to round them and to display them in different ways such as currencies or percents that make a little more sense for how we as people like to read and interpret data. But first, let's talk about the string class in greater detail. So as we've talked about, strings are literally strings of characters. Anything inside those double quotes counts as a string. And again, we can store strings in variable references and use them just like we can use objects. Now, something really important to understand about strings is that we talk about indexes in strings all the time. Now, when we talk about an index in the string, that's actually the position that a character is at in the string. We always start counting at index 0, and the first character of the string is index 0. So, in the case of the string hello world, capital H is at index 0, E is at index 1, and so on. And it seems like a pretty maybe trivial concept, but it's very important to understand that first character is at index 0 all the way to the end. Now, this brings about some interesting things because, again, we start counting at 0. So in the string hello world, there are 11 letters, but the indexes go from 0 to 10. So the length of this string would be 11, but the final index of the last index of the string would be 10. That's something that important to understand moving forward, is that we start counting at index 0. Spaces count, so hello space world. That space is at index 5. That does occupy an index of the string. We don't skip spaces or anything like that. Now that we understand indexes, we can talk about the methods a little bit more, because most of the methods that we deal with in CS 121 have to do with the indexes of strings. So first of all, we can get the length of a string. So the length method actually returns the length of the string, how many characters are in that string. So again, in the case of hello world, we have indexes 0 through 10, so that means that there's 11 characters in the string hello world. We have char at, so that's going to give you the character at a particular index. So the character at index 0 would be H, the character at index 7 would be O, and so on. Then we've got index of, where we can actually pass in a character and find out the index of the first occurrence of that. So if we called index of E, we'd get, lowercase e, we'd get 1. If you did index of space, you'd get 5, and so on. And then we've got substring in two different versions. We've got substring that just takes a beginning index that gives you the the rest of the string from a given index. And then you've got substring that takes a begin index and an end index. So let's go and actually type that up. And we can always consult back to this nice little hello world representation. So now I want to actually use some of these methods with you. So let me exit out of these. And I should already have, excuse me, a lesson 7, strings and format. Awesome. Forget you saw anything there. Alrighty, so let's make a string hello world so that I can go over that example with you. So we have this. Let's make sure that matches really quick. It does. We just want a capital W in there. So we've got our string hello world. And again, notice now that we know objects always start with, class names always start with a capital letter. Notice how string differs from int, num equals 5, right? String has a capital S, which tells us that this is a class name and that our string is actually an object. And just to prove that, I'm going to create the same string in a different way. This is a completely valid way to declare a string. And in fact, that's how you would have to do it if the creators of Java didn't put in a special shortcut for us. So the creators of Java knew that we'd be using strings so much that they gave us a shortcut way to instantiate them. So these two lines of code do the exact same thing. It's just that we have the double quote, the string literal method of creating a string, as a shortcut. So we don't have to type the new operator, we don't have to call the string constructor. We can just create our string and actually set it equal to a string literal, and that does the same thing for us. And so let's mess around with a couple of these methods. So we've got our string declared, so let's print out, and again, I'm actually going to call the method in the print statement. Let's use the length method first. So we already know that this should give us 11. Let's try it out. 11. Awesome. So let's try out another one. Let's do substring, and let's do 6. So that should be the index of the W, so we should just get world. Oops. There we go. And so again, substring, that takes one parameter, takes a beginning index, and gives you the rest of that word from that index on. Now let's try the other substring that takes a begin index and an end index. So let's try to just get hello. So the first index of the H is 0. So we just want to get hello. We should do 0 and 4. So let's try that out. So our beginning index is 0, and our end index is 4, and substring is going to give us the characters from that index, begin index, to the end index. So we should just get hello back. Let's see what happens. Uh-oh. First of all, I apologize. I didn't mean to create a cuss word in our console down there. But also, what the heck happened? That was a really bad joke. But anyways, we got hello. But instead we just got the first 4 indexes. So we put 4 as our end index, but we only got indexes 0 to 3. So what the heck is going on? So actually, another important thing to know is just like that boundary that we did in the next int in lesson 6, where it gives us a number from 0 to the boundary -1, we get the same behavior with strings, where we actually, when we use that substring method, we're going to get indexes from the begin index to the to the end index exclusive. So 0 is inclusive, which means we get the begin index character. It doesn't like start at the index after, so we wouldn't start at E here. We do get the H, but our end index is exclusive, so you don't actually get the character at that index. We get the character in the index before it. And so it does give us some kind of weird behavior. So to actually get hello out of this, we have to do from 0 to 5, and we'll actually get indexes 0 to 4. So kind of weird, but I want to show you why that works. So let's say we wrote a whole sentence after this. Or maybe we just have a bunch of exclamation points. I don't want to count all those exclamation points, but let's say I want world to the end of the string. So I know where world starts, but I don't know where it ends. And so what we can do is, we know world is at index 6. What we can do here is pass hello world dot length. And that'll give us from index 6 all the way to the end of the word, and we don't care how many indexes are left. Now, we could just do substring 6, right? And I'm not using a very good example here. There's other ones where this would make more sense. But what that allows us is, because length gives you the number of characters in the string, it doesn't give you the index of the last index, you can always use length and pass it into the substring method and have it work for you. And so the reason that it gives you from begin index to end index -1 is actually because our strings are 0 index, and that makes for some interesting behavior. So it actually, by doing that, allows you to do stuff like this. So we don't have to do length -1, we can just pass it length, and it just works. Another thing we could do is we actually could do hello world index of, and let's pass it capital H. So we get the index of the H. Oh, sorry, I meant W. And we go from wherever W is to the end of the string. Notice we get world exclamation point, whatever, how many times. And notice something interesting, index of actually takes a character as an argument. So I'm not double quoting this. It is a character, so I do have it in single quotes. So these substring methods, we use these a lot. You're going to get really great practice with them in today's lesson. You are going to do stuff like get index of and stuff like that. And so it's very important to understand and become comfortable with these substring methods. You're going to get really good practice with that in the add generator project. But with these methods, we can manipulate our output and strings that we take in and output that we print out. We can manipulate them very well and actually get some really nicely formatted messages that we print out to the user in our projects and stuff. We can also really manipulate strings that the user passes in, like we're going to do with our add generator program. So I wanted to take this opportunity to introduce another topic and concept that's very important. It sounds fancy, but really once you understand it, it's not too bad. However, it does affect the way Java behaves, and if you don't know about this, it can actually really impact your program's performance in the future when we start writing more complex programs. That is the fact that strings are immutable in Java. So what that means is that once we create a string, once we set name equal to Mickey Mouse here, it can't be changed. And so all the methods that return a string don't modify the string they were called on. They actually return a new string. So let me show that to you in practice here. Excuse me. So if we just have our string hello equals hello here, and we call hello.to uppercase. Now this is an important thing. There are uppercase and lowercase methods that allow you to convert your string from upper to lowercase. And let's, whoa, that is not what I wanted here. I have no idea what that class is. I wanted my good old sysout control space. There we go. So if we print out hello here, what you might have said when we first learned about methods and strings is that, oh, this is going to print out hello in uppercase because we just converted hello to uppercase. But notice that that's not what happens. So when we call hello.to uppercase, and actually let's go to the little mini documentation of it in here. I should be going to the string class, but it's right here in the slides, so I'll just show you here. Notice it returns a string, converts all of the characters in the string to uppercase using the rules of the default locale. So it does convert it. Let's actually go to the docs here. In the Java docs, returns a new string that's in all uppercase. So very cool. But notice that it doesn't modify the string hello. However, if we were to call it in here, you'll see that it does get printed out in uppercase. And so hello.to uppercase does not modify the string hello. It actually creates a new string that is a copy of hello put into uppercase and returns that. And that is because strings are immutable. So once we set hello equals string literal hello, that string cannot be changed. Now remember that this is creating a reference to the string hello. And so again, I could do string hi equals hello and print out hi.to uppercase, and it'll do that as well. And so, and if I set hello equal to a new string, and then printed it out, again, notice that it's going to be hello world now, and we've lost the reference to this string object. So once these are created, they cannot be changed. That's the essence of string immutability in Java. The last concept I want to demonstrate to you was string formatting. I did say at the beginning of the lesson we'd go over that. It's a pretty small part of this lesson, but it's important nonetheless, and you are going to be using it in today's activity. And so, first of all, if we're going to be formatting decimals, we need a decimal to format. So let's create double value, and we'll just do double num equals 5.0. Put those spaces in there so it looks nice, divided by 2. And let's print that bad boy out. You get 2.5. Awesome. So let's say we wanted a, let's call this non-repeat. And then let's create another one that's a repeating decimals. Let's do repeat equals, let's do 3, 1 divided by 3. That's a repeating decimal, right? Put those spaces in there so it looks nice. And we'll print out non-repeat, and we'll print out repeat as well. So we have a nice non-repeating decimal, and then a nice repeating decimal if I remembered the rules of integer division. There we go. So we've got 2.5 and then 0.33 repeating. So let's say we wanted to format our repeating decimal to 2 decimal places. We just wanted 0.33. The first thing we need to do is we need to create a decimal format object. So again, we're creating an object to do a particular thing. In this case, the decimal format class will give us objects that we can use to format decimals. They have methods that we can pass in a number and will return us a string formatted with a particular number of decimal places. Now, it has to return them as a string because otherwise it would be a repeating decimal still like this. Because doubles, you can't round a double to a certain number of decimal places. You could with the, excuse me, with the math class you can round numbers, but you can't print them out with a certain number of zeros. Notice that 2.5, if the zero is not there, it doesn't show. And if we have more decimals after 2, they do show. And so when you print out a double, it's going to show decimal places if they're there, and it will hide them if they're not. So I like to call my format objects just FMT, and we're going to do new decimal format. And we do have to pass it some parameters. So the first thing, let's just get this guy imported. Import decimal format. This is in the java.text package. Oh, and I forgot my equal sign. So the way we handle decimal formatting is we use what's called a pattern to format our decimal places. And notice we have to pass that pattern in the constructor, and it's a string. And the way the pattern works is we create our pattern with a decimal point and then either a hash or a 0. So what the hash does is it says format to this many decimal places, however many hashes there are, and if there's a number there, show it. If there's not, hide it. And so in a 0 would say show a number always. And so I'm going to say, I'm actually going to call this format 0, and I am going to put 2 zeros in there. And then I'm going to create another decimal format object to show you the differences between these. So first, let's actually format our non-repeating value. So I'm not even going to print out repeat. And we'll print 1 where we format, and the method to format is .format. So if you call the .format method on your format object, it's going to return this number formatted as a string to you. So let's do format 0, and then we'll do format no 0 .format, and we'll pass in non-repeat here. So what we've done is, again, we're going to pass in non-repeat into the format method here of format 0. that method is going to run, and it's going to return us a formatted string, and that string is what's going to get printed out. Because remember, whatever code's inside of the method call parameters is what's going to get run first. Same thing down here, but we're using our other formatter with our other pattern, and let me put the hashes in there. So these both will format our numbers to 2 decimal places, but it'll do it in different ways. And again, we're calling this on non-repeat, which would be 2.5. So format 0, where the pattern is 0.00, notice that we get 2.50. Even though there's not another number after 2.5, and you saw that when we printed out just the plain old double value, we got 2.5. Now, our decimal format is showing that with a trailing 0 at the end because we wanted it formatted to 2 decimal places no matter what. So this is the type of format you'd want to use if, say, you were formatting United States currency, right? Because our cents, our value, $1.50 is 1.50, right? We never say 1.5 when we're talking about $1.50. But notice the hashes print it, but without the trailing 0. So the hashes only show a number if there is a number there. And notice if we format repeat with both of them, we're actually going to see the same thing because, of course, in the case of the hashes, there is another 3 there in the, the hundredths place. And then with the 0, 0, of course, there's way more 3's than that. It's actually a long repeating decimal. So the final type of formatting I want to talk about is the number format class. This class differs a little bit from the decimal format class in that it's a little more specialized in what it does for us. And so I want to talk about that a little bit right now. So I'm going to switch this non-repeat value just back to num. I'm going to get rid of my decimal formats up here because I'm going to replace them, and I'm going to get rid of these print statements and replace them with just printing out our num value. Get rid of repeat there. Now, the way we instantiate the number format class is a little bit different. Let me get rid of that unused import up there. It's a little bit different because it's just number format. Again, I like to call mine FMT. And let's create the new instance here. And it's just open parenthesis, close parenthesis. The number format class doesn't take any explicit arguments in its constructor. But, actually, there is no constructor for the number format class. The number format, the way you get an object from the number format class is actually through a static method. Now, this is a particular type of method called a factory method because it literally is like a factory that produces objects for us. So this number format dot get currency instance actually returns to us a number format object that's already been configured to format numbers as currency. And what that does for us is, by default, if you don't pass it a certain country that you want to format your currency for, it will format your number for United States dollar. So 2.5 becomes $2.50 with the little dollar sign on it. So you can see that's a lot more convenient than having to use just a regular decimal format object and concatenating a dollar sign on the front. So you can get it for free. Now, if you want to switch up the country that you're using, you can actually pass get currency instance a locale dot, I believe, let's do UK. The United Kingdom, you are going to have to import this locale class. And the locale class just has a bunch of constants that are the country coded variables that allow us to specify what country we're formatting our currency for. So now this is like £2 and 50 pence, I believe would be the proper way to say that. And you've got the little British pound symbol there. They have all kinds of different locales that you can use. And the reason for these factory methods is that the creators of the number format class had some very particular use cases in mind. And the ones we talk about here are the currency instances, and then also another one you can use is get percent instance. Because a lot of times we'll deal with percents when we're doing our calculations. And so now let's do, instead of 5 divided by 2. Let's do 2 divided by 5, which should be 0.2. Sorry, that'd be 1 divided by 5. Should be 0.2. Let's print this out. So 0.2, oh, it should be saying 20%. Does anyone see the problem? Integer division strikes again. I'd like to say I made that mistake on purpose to illustrate that, but that was actually just a true mistake. So now we've got 0.2 will be displayed now as 20%. So everybody, I hope that's helpful for you. Should get you through the add generator activity, and I hope you learned a lot more about strings and how to format them. Talk to you later. Happy coding.